So this is our first unit. Role of the algorithms. First, I want to ask this question. Why do we need to study algorithms? Right? Yeah. I do not want to hear, for the degree purpose, although that's true, but here, our main goal, we want to solve real-world problems, real-world computing problems, computer science. So we will solve real-world computing problems. Okay. So you will be a computer professional because you get the training like this. So you will become a computer professional sometime. Okay? So you need to solve a lot of computing problems. Okay? Yeah. So when you solve computing problems, do you need algorithms? And what are the algorithms? Especially, I want to explain what are the algorithms. Yeah. So most of the time, if the problem is very easy, you may not need fancy algorithms. So you can solve, in a trivial way. But I think you worry about solving hard problems. Okay? So we want to look at those cases when you solve some difficult computing problems. So here, I want to look at the factors that may help you solve the problem. Okay. So what preparation do you need? First, do you need some strategy? Right? The problem is very difficult. Okay. You do not have an idea. At the beginning, you do not have any idea how to solve it. Okay. In this situation, do you need any strategy? Right? So in this class, you will see we will use a lot of strategies. Okay? So you need to learn a lot of strategies, especially for really hard problems. Okay? So that's very important, the highest level. Okay? Yeah. Simple example, playing chess. Do you need a strategy? Right? Playing chess is hard, right? Yeah. So world champion, that level, right? It is really hard. So playing football, do you need a strategy? Right? To win the, Super Bowl. It's not easy, right? So definitely a lot of strategies should be developed. Right? So you may argue playing football, it's not a computing problem, right? It's not a computing problem. But we can easily generalize from the computing problems to real-world problems. A lot of things common. Strategies, it's common. Okay? Yeah. All right. Definitely playing chess, we can treat as a computing problem, right? AI. Okay? When you use AI to solve, chess problem, AI be the human champion in which year? Which year? The first time AI, chess, program, IBM, Deep Blue, be the world champion. Gary Kasparov, right? 1996. 1996 milestone. Okay. Although in that year, AI didn't defeat Gary Kasparov that year, 2-4. Yeah. So, but next year, 97, AI beat the human champion. Okay. Yeah. So to write AI programs, it's a difficult computing problem, right? So definitely you need a lot of strategies. Okay. So we can treat that as a tough computing problem. Okay. Do you need an execution plan? Suppose you have a strategy, right? Yeah. So you have a strategy already. Okay? But how to execute it? How to make it happen? That's not easy, right? Yeah. You have the winning strategy, but you cannot execute it. you still lose, right? So look at the football. Okay? You have the strategy, great strategy, but your players cannot execute the plan. Okay? Yeah. So another factor. So that's also important, this factor. Okay? And this factor, your discrete math. If you have a very solid discrete math background, you can execute your plan. Otherwise, you cannot execute your plan. Okay? Yeah. All right. Okay, yeah. Now, at the end, you need to have an algorithm to solve the problem. Okay? Yeah. Suppose you have the strategy, you know how to execute the plan, how to make it happen. Okay? Finally, you need to write an algorithm to solve the problem. That's the step-by-step implementation of your whole plan. Okay? Yeah. So now I want to describe the algorithm. Yeah. So now try to define it, because if for the definition, so you have to consider, very precise, very accurate. But for description, so we can, make it a little loose. We just, talk about some properties of an algorithm. The goal, find a solution for a computing problem. How to get a solution? We need a precisely defined procedure to get the answer. Okay? Precisely defined, step by step. How do you define the procedure? The first step, what do you do? Okay. All right. So implementation details must be there. Okay. Each step can be represented in code. After you describe your implementation detail, you can translate it into the code. If you do not have that one, you cannot, because eventually you need to write a computer program for it. Okay? Yeah. So it results, finally, you will get a computer program. Okay? Yeah. Yeah. Oh, by the way, at this point, because for our first lecture, I haven't posted lecture notes. Right? So this PPT, I haven't posted. But in future lectures, before the class, I will post my PowerPoint slides. Okay? So I try to post it about 1 day before the class. Okay? Yeah. All right. What is an algorithm? Yeah. So now, actually, I think you understand pretty much the picture. You'll see the picture of this algorithm. Yeah. Elements in an algorithm. Okay. So it is a sequence of instructions. Okay? Yeah. So at the beginning, it could be in pseudocode. Yeah. So not necessary in computer code, but we will translate those pseudocode to computer program code. Yeah. Yeah. It should be unambiguous, okay? Very clear. Okay? So not just clear to you, it should be clear to other people who read your algorithm, read your step-by-step description. Yeah. Yeah. You need to have input. Yeah. So you write a program to process data. So input. You need a data as your input. Okay? Think about if your program does not process anything, it's useless, right? So its main goal, you need to process data. input. Okay. All right. So it is required. All right. Yeah. Then output, processing result. You need to produce the output, the result, following the business requirements. Okay? So input, output. Yeah. That's the elements of your algorithm. Yeah. But your output must be in required format. Right? So following the business requirements. The format, your customers want this particular type of format. Okay? Yeah. All right. You also need to consider execution time. How fast your algorithm is, or how fast your program can run. So execution time or response time, extremely important. Yeah. So in this class, we will spend a lot of time work on this part, execution time. Okay. Even before we run the program, we do not run the program. But in this class, during the lectures, we cannot run any program, right? Yeah. But we can find out how fast is the execution time through rigorous mathematical analysis. So that's the reason we need to use discrete math, not just discrete math. We also need to use calculus, derivatives, right? Limits, find the limits, derivatives. Yeah. So that's why, we require a lot of math. Okay? Yeah. I hope you're not get scared. Yeah. But I try my best to cover the details. Yeah. Yeah. You just need to recall that part of the knowledge. Okay? Yeah. All right. It must be finite amount. Okay? There is a termination. Otherwise, if your program can never terminate, it's useless. Right? It must be, terminated at some time. Yeah. Hopefully in a short time. Right? Yeah. How long? Yeah. Based on the problem. Sometimes if the problem is huge, nobody expects it can produce the output in a fraction of seconds, right? Yeah. If the problem is, landing on the moon, things like that, right? It's a huge, big, tough problem. So nobody expects. So based on the problem, the execution time should be acceptable to your users. The users feel that's okay. So the users or the customers are willing to pay for your solution. Right? You develop the solution, sell to your customers. Your customer will pay for it. Right? So you need to deliver acceptable performance. Must be acceptable. Yeah. So you can understand that easily. Yeah. All right. Next, how to get an algorithm. Yeah. So now I think we understand more and more about the algorithm. Now we want to do it. We want to create it. We want to develop algorithms. Algorithms, right now, it's critical. Now, I think most of you heard of AI stories, right? Many AI stories. Okay, so here I do not, talk about the details, AI stories. What is AI? What is the central piece of the AI? Algorithms. If you control the algorithms, AI algorithms, you control the success of AI. AI success story relies on algorithms. One big story, so I doubt many of you may not know about it. So this year, 2020, about 4 years ago, 2016, there is a huge story. That was a huge story. So anybody knows, heard of, there is a huge AI story in 2016. Anybody has some idea? 2016, in March, specifically in March, mid-March, there is a huge milestone in AI. So anybody knows a little bit about it? 2016. Yeah. Google AI program, it is called AlphaGo. Any idea? AlphaGo. Go. Game, like chess, but it's a Go game. Okay? It's a traditional Chinese game, more than 2,000 years old. Go. Okay? Black piece, white piece, on a board with grid. Okay? 19 by 19 lines, grid. Okay? So two players play, Go pieces, black, white pieces on board. The player who occupies more territory, you control more territory, it's the winner. Okay? For the Go game, it is much more difficult than chess game. 100 times more difficult than chess game. Okay? Yeah. From the possibilities. Yeah. So usually, people, Go professionals, usually they predict computer, AI, cannot beat human champion in, let's say, 50 years. Okay? Large number of years, 50 years. Yeah. But that happened in 1916, March. I still remember, because it's a big story for me. Okay. I still remember the period it happened from March the 9th to March the 15th. In that week, okay, Google AI AlphaGo program versus human world champion, South Korea world champion Lisa Do, okay, world champion. He won 10-something, 14 world champions. Okay, he's a genius. He won 14 world champions in the world. Okay, yeah. Google AlphaGo beat Lisa Do 4-1. Huge margin, 4-1, 5 games for $1 million. The prize, $1 million. The prize. Okay. 4-1, landslide win. Why landslide? Yeah, because it looks like Lisa Do won one game back, right? But actually, because I'm a Go fan, so I watched all 5 games from beginning to end. Each game 5 hours. The Go play, really long, 5 hours. Okay? So I enjoyed that 5 hours. And it's at South Korea, so you know the time difference. South Korea, okay? When they play at noontime, South Korea. Here it's midnight. Okay? So I need to watch at midnight. Okay? Yeah. After I finished my evening class, so I drove back, at already 11 o'clock, but it's fine. 1 more hour, I can enjoy the game. So I spent 5 hours, enjoy the whole game. Okay. Why landslide? The first 3 games, AlphaGo beat Lisa Do 3-0. Okay? Huge difference. Okay? Lisa Do has no chance. Then the 4th game, suddenly AlphaGo collapse. Make silly mistake, ridiculous mistake. Even I cannot make that mistake. Okay? So I'm a bottom amateur. I'm not a good player. Even I cannot make that silly mistake. Just intentionally gave one game away to Lee Sedol. To encourage Lee Sedol play the 5th game. Because based the contract, no matter winning or lose, they have to complete all 5 games. To encourage Lee Sedol. Otherwise, Lee Sedol will give up. Okay? That huge difference. So the reason I give you this story, I want to show you the power of algorithms. Because why it can happen. The Google team, in Google AlphaGo team, actually this team Google bought from British. Google has a lot of money. So they spend about $500 million to bought a team. Just bought that team. British. Yeah. Bought that team. Then, they have a lot of computing power. Yeah. Yeah. They use a lot of computing power. Then they can beat. But why they publish their algorithm in Science journal? Science. Okay? Yeah. So I can post their paper, okay? Yeah. Just for your interest. Yeah. Although it's hard to understand. That story. So people even compare that big milestone with landing on the moon. That big. Its impact. Why AI is so popular today? Since that week. Before that week, AI is not that hot. AI was not that hot before 2016 March, mid-March. Although people doing AI, but no big investment. Yeah. Not many people want to invest AI. Keep losing money. Keep losing money for about 50 years. Before that, all the investment, all lost. Okay? But that one, after that, now, how many people, how many companies invest in AI? That's the starting point. Okay? All right, so let's continue. Okay. So in this course, we will study all the details. So how to develop algorithms to solve what kind of problems? Basic computing problems. Okay. All right. We need thinking. Yeah. Thinking is the critical thing for this. When you design, you need to do a lot of thinking. Strategies, right? Yeah, that's part of the thinking. Okay. Analysis, yeah. All the details in the thinking. Okay. Then analysis. After you come up with an algorithm, is it good? Do you know it's a good one or bad one? Right? So before you can write a program to test if it's good or not, you can already do analysis. You can find its performance or efficiency. Okay? Yeah. So based on our math calculation, we can get that. Okay? Yeah. So you can see for this class, we will do these two things, design and analysis. And another one, okay? Implementation. Because we have 3 programming projects, so you need to implement it. Okay? Design, analysis, but finally, you have 3 programming projects to complete implementation part. Okay? Yeah. So I hope so after these a few slides, you can see the overall picture for this class. Yeah. So any question so far?